2.1, fundamental identities. So the first group of identities, we'll call them reciprocal identities. And the name tells us that we're going to talk about reciprocal functions. So sine of x is 1 over cosecant, and then cosecant of x will be 1 over sine. So they go in groups. Cosine of x is 1 over secant, and then secant is 1 over cosine of x. Tangent, and perhaps I will write it underneath here. Tangent of x is 1 over cotangent, and cotangent of x is 1 over tangent. So this is the group of reciprocal identities. The second group, we'll call them quotient identities. So tangent is the quotient of sine and cosine, and cotangent is the ratio or the quotient of cosine over sine. So just two of them in this group. And then the most important one, Pythagorean identities. Pythagorean identities are 3. So the first one is the most popular, sine squared of x plus cosine squared of x is 1. Then we have 1 plus tangent squared of x. By the way, this is very easy to prove, especially the second one. We can prove it using the quotient identities. So 1 plus tangent squared of x is secant squared of x. And the last one, 1 plus cotangent squared of x, is cosecant squared of x. Another group, we call them cofunction identities. So they go like this. Sine and cosine are connected. The difference between them is pi over 2. So sine of pi over 2 minus x is cosine of x. And on the other hand, cosine of pi over 2 minus x is sine of x. So they go in pairs. Tangent goes along with cotangent. And so then cotangent of pi over 2 minus x will be tangent. And what's left, secant, goes with cosecant. And then cosecant of pi over 2 minus x will be secant of x. So they pair like this. Even in odd identities, so we know sine is an odd function, and therefore cosecant, because cosecant is 1 over sine, is also an odd function. Tangent is odd, and therefore cotangent, which is the reciprocal of tangent, is also odd. So these are odd, and what's left is the cosine, which is even, and what's the reciprocal of cosine? Secant, so secant is also even. So 2 even and 4 odd. So example, using identities to evaluate a function. Using identities to evaluate a function. So if secant of u is negative 3 over 2, and tangent of u is positive, find all 6 trig functions. Well, 5 because one of them is given. So secant is given. What's the first function we can find? Secant is related with the cosine because it's the reciprocal. So we can write the cosine of u is 1 over secant. So the reciprocal will be negative 2/3. So we found cosine. Next thing, we can find sine. From the Pythagorean identity, sine squared of x or u, okay, is u, plus cosine squared of u is 1. Therefore, sine squared of u would be 1 minus cosine squared of u. We substitute. So that's 1 minus 4/9 or 5/9. Now that's the square of the sine. So sine of u would be normally plus minus square root of 5 over 9, which is plus minus square root of 5 over 3. But tangent of u positive, that tells us we are either in the first or third quadrant. Now, cosine negative tells us cosine is negative. That means, let's write this down. Cosine of u is negative. That means u is, the angle is in third or second or third quadrant. So u is in the third to meet both requirements. And in the third, sine is negative. So sine of u is negative root 5 over 3. So what's left now is tangent, which is sine over cosine, and negative root 5 over 3. Cosine was negative 2/3. So root 5 over 2. So tangent's positive. What's left? Cosecant. Cosecant of u, which is 1 over sine. And so that's the reciprocal of sine, negative 3 over root 5. Rationalize. So we found that. And it's left cotangent, which is 1 over tangent of u. So 2 over root 5. Rationalize 2 root 5 over 5. So we found all of them. Example 2. Simplifying trig expressions. So the first example showed us how we can use the identities to evaluate other trig functions if one is given. And the second case is to simplify trig expressions. So for example, simplify sine of x, cosine squared x minus sine of x. So we can factor out sine of x, cosine squared of x minus 1. And from the identity, note, we're using the identity sine squared plus cosine squared equals 1. And from here, cosine squared of x minus 1 is negative sine squared of x. So here we're going to substitute. Instead of cosine squared minus 1, would be negative sine squared of x. So that is equal to negative sine to the third x. Another example. Tangent squared x minus tangent squared of x sine squared of x. So the same strategies, we factor tangent squared inside 1 minus sine squared of x. We know 1 minus sine squared of x is cosine squared of x. So we had that earlier here, the same identity. And finally, we can write tangent squared as sine squared of x over cosine squared of x. And we see how this cosine squared cancels. Finally, we have sine squared of x. Another application of the identity will be factoring trig expressions. So we did a little bit of factoring in the previous example, but factoring trig expressions. So for example, secant squared of theta minus 1, we're using the formula a squared minus b squared, a minus b, a plus b. So that becomes secant theta minus 1, secant theta plus 1. Okay, so let's have that a, b, 4 tangent squared theta plus tangent theta minus 3. We can factor this just like we factor quadratic trinomials. So for example, 4x to the third plus x minus 3. We can factor this by guess and check or by AC method. So 4x minus 3 plus 1, we can check by foiling. So we're using the strategies here. Instead of x, we have tangent of theta, so that would be 4 tangent of theta minus 3, and here tangent of theta plus 1, and it's factored. We can also add and simplify expressions, trig expressions. So for example, if we have to simplify sine of t plus cotangent of t cosine of t. First thing we're going to do is rewrite it and write cotangent as cosine over sine. And then we need the same denominator, which is sine of t. And I can rewrite this as sine of t over 1 plus cosine squared of t over sine of t. And now we can multiply by sine of t, top and bottom of the first fraction. And we have sine squared t plus cosine squared of t on the top. We can add them now to have the same denominator. And the numerator is actually 1 over sine of t, which we know is cosecant of t. So another example where we have to add and simplify. Sine of theta over 1 plus cosine theta plus cosine theta over sine theta. So the LCD is sine theta, 1 plus cosine theta. So we're going to rewrite this. The first fraction has a denominator 1 plus cosine theta, but does not have sine of theta. So we want to multiply top and bottom. The second fraction has sine theta, but does not have 1 plus cosine theta. So we're going to multiply top and bottom. So now both fractions have the same denominator. So we can multiply sine times sine is sine squared theta plus cosine theta plus cosine squared theta. So I add it and distribute it here. The denominator is the same sine times 1 plus cosine theta. Now we notice here sine squared plus cosine squared is 1. So it will be 1 plus cosine theta on the numerator, and denominator, we notice we can cancel 1 plus cosine theta. And so what's left is 1 over sine theta, which is cosecant theta. And this concludes the video.